Hello guys, welcome to Pepcoding, and today we will gonna solve this question of level up remove first in doubly linked list. So first of all, let me tell you the question statement that what our question wants from us and what is doubly linked list. Okay, so think it like this. We have a linked list. If you have done level 1, you know what the linked list is. So let me tell you again that for example, if we have 14, let me change it, 14, then 10, then 11, then 21, then 41, then 7, then 8. So in linked list, everything is connected in this manner, right? If it's a normal linked list, everything singly linked list, everything is connected in this manner. But in doubly linked list, what happens is there is also one more pointer for this direction also, right? So the thing is our structures are connected, or I can say our structures are interconnected. Like if there's 14, so 14 has this kind of structure, and here is the address for 10, and here is the address for its previous node, and for 10 this is the address for 14, and here is the address for 11. So doubly linked list is something like this. So what our question is, remove first in doubly linked list, DL, right? So what we need to do is we need to remove this element, right? This is our question statement that we have given a doubly linked list and we just have to remove this first element. So if you think about it, there are some of the edge cases. First of all, let's understand what are some of the edge cases for this question. So first is, if linked list is null, if or I can say if there is no head, what will we do if there is no head? Then the second is, if there is only one element. So these are two edge cases, and one more thing, and there's third case is intermediate. Like except these two, every other case is a third case, right? So now we have to understand some things like how we can handle this case and this case and this case. These are three things. Visualize. If first of all, let's take this linked list. So if there is a linked list and there is no element, like there is no element, it's null. Linked list is what? I can say linked list is null. If there is null linked list, like there is nothing, can you remove something from it? No, it's not possible. Because if there is nothing, what can you remove? Exactly, that's my point is. Then there's second thing, if there is only one element. So for example, if there is only 14, there is nothing, there is only 14. In this direction of 14 is null. In this direction of 14 is also null. And we have asked, and both head is here and tail is also here. And we have asked to remove its first element. So the thing is, this is the first element, right? So we have to remove what? We have to remove 14. But if you remove 14, this linked list will convert it to this linked list of null, right? So if you remove 14, which is the only element present, our new linked list after removing will be null. And head will point to null and tail will point to null. This was our first case. This was our second case. Let's talk about third case, which is something like this, right? So if there is, let's say, three elements, like I'll say 10, 11, 17, and both are, let me take a bigger example, not bigger example, but bigger in, see, like if there is 14, and then there is 17, and then there is 19, and we have asked to remove the first element. How can you do that? Like first of all, we know that head is here, right? So we have to remove this element which is on head. So first thing we can do is, first of all, I will give you just an overview. So what I will do is, I will take this head and I will point it to this direction. But if you see, this is what we did in our singly linked list. Like if we have only singly linked list, we take our first head and put it to the next element so that first element will be removed. But here there is a hack. If you put head here, this link is also here, right? That means you can access 14 from 17. In singly linked list, you cannot access 14 from 17, but in this linked list you can access. So if you can access, that means 14 is already there, 14 is also present, you can access it. So there is one more thing you need to do. You have to break this bond. What bond? You have to break this bond, because if you see the first element of our linked list have null in this side, but now if you move our head only, there is no null in this side, 14 is in this side, right? So these are things which we need to take care. So now what I will do is, see, I cannot directly take head to here. Before that I need to do some more things. Okay. I cannot directly go there. So what I can do is, first of all, I will take one more pointer as forward. Which is pointing towards our second element, right? And then what I will do is, I will break this bond. I will say head dot next is equal to null. So this break is broken. Now I will do second thing, which is we have to break this bond. How I can break this bond? So I can do forward dot previous is equal to null, right? So I have broken this bond. Now 14 is on its own, 14 is not connected, and what I can do now is head is equal to forward. So what is happening right now? Our head, this was our head element, sorry, head pointer, this was our head pointer, now it pointed towards 17. So now 14 is removed. Very simple, right? It's simple. So the thing we have to take care is these three cases. If there is no head, if there is only one element, and intermediate stage. So if there is no head, that means our linked list is null. If it's null, we have to do what? Nothing. We cannot remove anything. There is an exception we have to handle. It is given in our code and I will tell you. And the second thing is, if there is only one element present. If one element present, what we have to do is, we have to make head and tail both as null. And then there is intermediate stage, where we have to remove first element. So what we have to do when we remove first element, we have to break the bond between them, and we have to just take two pointers and we have to do this. Head dot next is equal to null, forward dot previous is equal to null, and head is equal to forward. Now let's go to our code and let's code it. So we have given some of the functions for Doubly linked list, to string, and yeah, this is what I was talking about, exception. Like if size of linked list is 0, we have to say list is empty and we have to return true. Okay, and add first this is we have to complete what? We have to complete our remove function. So now first of all, let's take care about exception. Okay, this is not working. Yes. Okay, this is now. So first of all, we will take care about our exception. So if I will call that function, if list is empty exception. If list is empty exception. So if this exception occur, what we have to do is we have to return -1. First thing, and the second thing now is, okay, so I will not do everything in this function, right? I will make another function in which I will handle the other two cases. If exception occur, then this function will handle it. But for other things, I will make another function. For example, I will make node is equal to remove first node, and at last I have to return node dot data. Simple. So now let's make our remove function, which is more interesting now. So what I have to do is I will make it private. Node is equal to remove first node. And in this function, sorry, this is a function, right? So I have to make it something like it is returning our node which we have to remove, right? So I will do node is equal to this dot head. First of all, what I did is I save our so sometimes this happen. This is our head, right? This is our head. But just for the safety, I am taking another pointer node which is also pointing to head, so that I will not I will not disturb my head. So that's why I'm taking node also, just for the safety purpose. Okay. So yes, this dot head. Then I have to do is what if I have to check if this dot size, if the size of our linked list is 1. What does this mean? If there is only one element, if there is one element, what I have to do is this dot head is equal to this dot tail is equal to null, right? We have to and again I will show you. This was the case I am talking about. This was the case I am talking about. If there's only one element, what I have to do is I have to make head and tail both null, right? So let's make it. It's done. Now the second case, else. If size is not null, if the stage is intermediate, if you remember, what I have to do is node next node. I take a next node which is this dot head dot next. Then what I have to do is next node previous is equal to null. First of all, I take my next node pointer as head next. Then I have to break the bond. So next node previous is equal to null, and also node dot next is equal to null. These two lines, these last two lines are doing what? Are breaking the bond. And at last I have to do what? This dot head is equal to next node. I have to update my head. And after that I have to also change its size, because now 1 is removed, so size will be decreased. And also I have to return node which we have removed, right? So okay, these two cases, right? These two cases. So these two lines are doing what? These two lines are what? Doing what? Breaking the bond. So if node previous, what I did was, this is head, and let me take one more element like 18. So this is head, so I put my next node here, and I'll do what? This is here I have to put a dot. So next node previous, this bond is broken by this line, and node dot next has been broken by this line, because this is also node. So these bond is broken now, and this is our new head. So this line is updating our head. Then if this is removed, we have to decrease its size, and after that I have to return this value, right? So there is one mistake which I just found, that I have to do what is node previous. Now just run this code and see if it's working fine. Okay. It is taking longer than usual. Accepted. Now submitted. Sorry for that. Let me log in it again. Hopefully our code wasn't lost. Okay. So hopefully, okay. Yeah, our code is already here. Let's submit this code. And I hope there will be no error this time. So correct answer. So if you understand my concept, if you understand what we have to do in this question, how we have to do this question, so like the video. If you have any query regarding it, you can comment it out and subscribe to our channel. Thank you so much, guys.